Hello everybody, welcome to your 9-3 lesson on rewriting radical expressions. So our learning target for this lesson, we will write equivalent radical expressions. We'll use properties of exponents to rewrite radical expressions. We will multiply some radical expressions, and we also will be able to write a radical expression to model or represent a real-world problem. So we have some vocab to cover to get us ready for our lesson. First is something that we call a perfect square factor. Well, why don't we just cover what a perfect square is before we go into what a perfect square factor is. So perfect squares if you take a number and you multiply it by itself, so 1 times 1 and you get 1. 2 times 2 gives you 4. 3 times 3 is 9. We also could, instead of writing out 3 times 3, you could have said 3 squared, or let's say 4 squared is 16, 5 squared is 25, and we could continue this list forever. So those numbers, the 1, the 4, the 9, so these numbers that we get when we square our integers, 1, 4, 9, 16, 25, those are perfect squares. All right, now what's a perfect square factor? So we have found factors. We do this often when we are factoring. So let's say we've got 12 and we're thinking about all of our factor pairs for 12. Well, one of the factor pairs is a 4 times a 3. Those are factors of 12. The 4 is a perfect square factor. It's a factor of 12, but it's also one of our perfect squares, one of these guys. One thing to take note of, your perfect squares, the 1, 4, 9, 16, 25, they square root perfectly. So this perfect square of 4 can be square rooted without getting a decimal. The square root of 4 is 2. Another example, let's say we have 18. So does 18 have a perfect square factor? Well, it does. 9 times 2 is 18, and 9 is a perfect square because you can square root it perfectly. It's also the result of squaring 3. 3 squared is 9. Okay, so those are our perfect square factors. Now let's move on to what a radical is. Well, that's a radical. You guys have seen that before. We call that a square root. Just so you know, when you get into Algebra 2, you're going to learn that you can take more roots than just a square root. You can take a third root, a fourth root, a fifth root. But through algebra, we just worry about square roots. Those are our second roots. We know that 4 squared is equal to 16. So then the square root of 16 is equal to 4. It's kind of like the opposite operation for squaring. All right, a radical expression, that is an expression with a radical. And this is what our whole lesson is going to be about, these radical expressions. So, for example, here's a radical expression. A radicand, if we go back to this, 25x to the third power, that 25x to the third power is the radicand. It's the value that you're taking the square root of. All right, and then last we have something called the product property of square roots. We're going to use this a lot in this lesson. if you multiply, or if you take the square root of a product of a times b, that is equal to the square root of a times the square root of b. That's when a and b are greater than or equal to zero. So are non-negative numbers. So every square root, whatever you're square rooting, can be broken down into the product of two square roots.